Imagine two glasses of water, one from your tap, one from the ocean. At first glance they look almost identical, both are clear, cool, and refreshing. But don't be fooled by appearances. Take a sip from each. Tap water is plain, maybe even a little sweet or metallic depending on where you live. But ocean water? It's shockingly salty, almost undrinkable. That intense, salty taste is a clue to one of Earth's coolest mysteries. Why is the sea salty, while the water from your tap is not? The answer lies in what's dissolved in the water. Tiny particles and minerals you can't see, but your taste buds definitely notice. Tap water is filtered and treated to be safe for drinking, with most impurities and minerals removed. Ocean water, on the other hand, is packed with minerals, especially salt. The main salt is sodium chloride, just like the salt you sprinkle on your fries. But ocean water also contains many other minerals like magnesium, calcium, and potassium, all swirling together. This salty mix has been building up for a very, very long time, millions of years in fact. Every drop of ocean water holds a story from Earth's past. So where does all this salt come from? It's not dumped in by accident, it's a journey that starts on land with rocks, soil, and rain. Rain falls on rocks, slowly breaking them down. Rivers carry tiny bits of minerals and salts from the land all the way to the sea. Over billions of years these forces, rain, rivers, and time, have turned our oceans into salty giants, constantly collecting more minerals. The ocean is a collector, gathering minerals from every continent, every river, and every rainfall, mixing them together in a vast, swirling system. Covering over 70% of Earth's surface, the ocean is a massive, connected system that links every corner of our planet. Asking why the sea is salty is really asking about the history of our planet, how land, water, and time have shaped the world we know. The answer connects the highest mountains, where rivers begin, to the deepest sea trenches, where the journey ends. Ready to dive into the science of salt and discover the secrets hidden in every drop of seawater? Let's go. The story of salty seas starts with rocks on land, where the journey of every grain of salt truly begins. Rainwater, which is naturally a bit acidic, slowly dissolves the surface of rocks, releasing minerals and salts into the environment over time. As streams and rivers flow across the land, they pick up these dissolved minerals, carrying them along on their winding paths. Every river acts like a conveyor belt, transporting a tiny but steady supply of salt and minerals toward the sea day after day. River water doesn't taste salty because the concentration of salt is very low, almost unnoticeable to our taste buds. But the salt is always there, hidden in the flow. Rivers can travel thousands of kilometers, winding through forests, plains, and cities, collecting even more minerals and salts along the way. Groundwater, seeping up from deep underground, adds even more minerals to the mix, enriching the river's mineral cargo. All rivers, no matter how big or small, eventually empty into the ocean, delivering their load of minerals and salts to the sea. Imagine every river on Earth, working together day after day for millions of years, steadily adding salt to the sea and shaping the chemistry of our oceans. It's a slow, relentless process, happening so gradually that we barely notice it, but over time, it transforms the world. This is the first big step in understanding why the ocean is so salty, a story written by water, rock, and time. The salt's journey is one way, straight to the sea, where it becomes part of the vast salty expanse of the ocean. Rivers keep adding salt to the ocean, but there's almost no way for salt to leave. The ocean is like a giant savings account. Salt goes in, but rarely comes out. Over billions of years, these tiny deposits have added up. River water is diluted, but in the ocean, salt accumulates. Water leaves the ocean through evaporation, but the salt stays behind. Ocean currents and waves mix the salt throughout the globe, making all oceans salty. Some salt is used by marine life or settles on the seafloor, but most stays dissolved. The result, a stable, salty environment that supports ocean life. Small changes over time create big results. The water cycle is key to the ocean's saltiness. The sun heats ocean water, causing it to evaporate, leaving salt behind. Only pure water rises as vapor, salt stays in the sea. When water vapor cools, it forms clouds and eventually falls as rain. Some rain returns to the ocean, but much falls on land, starting the cycle again. Rivers dissolve more minerals and carry them back to the sea. This cycle purifies water but keeps adding salt to the ocean. Water makes a round trip, but salt's journey is one way. That's why the ocean keeps getting saltier over time. It's a beautiful, elegant system. The ocean's saltiness is a story of endless cycles and patient science. Now let's take a journey to the legendary Dead Sea, one of the saltiest and most unique places on our planet. This remarkable body of water has fascinated travelers, scientists, and explorers for centuries, and for good reason. While the average ocean contains about 3.5% salt, the Dead Sea boasts an astonishing salinity of nearly 34%. That's almost 10 times saltier than the world's oceans, making it a true natural wonder and a record holder for saltiness. But why is it so salty? The Dead Sea sits in a hot, arid region where rivers like the Jordan flow in, but no rivers flow out. It's a closed basin surrounded by desert with no escape for the water except through evaporation. As the intense sun beats down, water evaporates rapidly, leaving all the dissolved minerals and salt behind. Over time, this process concentrates the salt to extreme levels. Over thousands of years, this cycle has created a super salty brine, so dense that it's almost impossible to sink. The water is so dense and buoyant you can float effortlessly on the surface. Many visitors even read a book while drifting. But this extreme saltiness means it's far too harsh for fish or large plants to survive, hence the name Dead Sea. Only a few types of microbes can call it home. The Dead Sea is a real-world example of what happens when salt keeps coming in but can't get out, creating a landscape both beautiful and barren. Our oceans are salty for the same reasons, just on a much bigger scale. Rivers bring in minerals, and evaporation leaves the salt behind. So next time you see a river meeting the sea, or gaze out over the waves, remember the incredible salty journey that's been shaping our world for millions of years.